Hello and welcome to this video on rate of change. Rate of change is a very broad area, but for right now we're going to look specifically at determining if a data set is linear or not using the idea of rate of change. Now when I say linear, it would just be so easy to sort of graph the data set and say, hey, it makes a line. But we're going to try and talk about knowing if a data set makes a line without actually making its graph. Okay? So we have a rule here, and the rule is a data set of x and y is said to be linear if and only if, and here's the big moment, delta y over delta x is constant for all x and y pairs in the data set. Okay? Now there's some things I'll have to talk about here. If you heard me, I used the word delta y and delta x, which is this Greek symbol. It's the triangle here. And what it means is change, okay? And quite simply, it means if I have a value of a number that's maybe 5, and then its new value becomes 9, its change is in fact plus 4, okay? So the delta here, or the change, equals plus 4, okay? And when I model this in an actual problem, it'll become much easier. So now we have, what do we mean by constant? We need to look at this. A constant means it's never changing, okay? It means it's the same all the time, okay? So there's a couple things we need to be able to compute here, okay? And it says we've got to compute delta y divided by delta x, and we need to do that for all xy pairs in the data set. And if we get the same answer all the time, that means the data set is in fact linear. So we're going to take a look at a couple examples of this now and apply this idea. Okay, so the one thing I need to do is copy this formula here and go to my next slide and paste it on. And we need to be able to be mindful of this idea that delta y over delta x is constant. So each of these, if you notice, is a data set of x and y. Okay? This is just the raw math of this situation. The real applications of this come where you talk about relating maybe distance and time or miles per gallon, things like that, where you're studying the simultaneous change of two quantities that are related to each other. But for right now, we're just looking at x's and y's. And this is the basic principle here. Okay, so if you notice in my first data set, I have an x column and a y column. And what I'm going to do here is make an additional column called delta y, and an additional column here called delta x. Okay, so my delta x, again, is how much my value of x changes. And in this column, it's very easy to see that they're all changing by ones. Okay? And then if I look at my delta y's, to go from 56 to 46 means you're going back 10, so it's negative. 46 to 36 is also back 10. And 36 to 26 is also back 10. Now, this looks very patterned, but you have to be formal about this, okay? Because they need to be able to look up here, like it says, at delta y divided by delta x. So I'm going to, in fact, make those ratios right now. Okay, so we have here, the first one is just delta y over delta x equals negative 10 over 1, which is equal to negative 10. And then the second one is also negative 10 divided by negative 1, 1, which is also negative 10. And then the third one, it's pretty easy to see that that is also equal to negative 10 over 1. So that, in fact, is negative 10. Now, what have we seen here? That delta y over delta x is the same all the time. That means that this, in fact, is a linear data set. Okay? You can kind of feel it in your gut once you see that the change in y is the same every time, and the change in x is the same every time, that the idea that this is linear should be a decently uh, easy one to grasp if you just kind of follow the idea that delta y over delta x is constant. Okay? Now, in this next data set, again, I'm going to take a look at delta x and delta y because I, in fact, do need those to be able to determine if it's linear or not. And again, just to review the idea, a data set is linear if and only if delta y over delta x is constant for all xy pairs in the data set. Okay? So again, my delta x is decently easy to measure here. It's just a coincidence it's the same as the last one. It seems that my delta x is going up by 1 every time. Again, it's the change. The change from 1 to 2 is 1. The change from 2 to 3 is 1. And the change from 3 to 4 is 1. Okay? Now here, the change from 3 to 5 is plus 2. And 5 to 9 is plus 4. And from 9 to 15 is plus 6. Okay, so we see here that we have this 1, 1, 1, and then 2, 4, 6. And both of them are, in fact, patterns. But you have to realize we're not looking for any old pattern. We're looking for the ratio of delta y over delta x to be constant. So again, we're going to examine delta y over delta x for each ordered pair. So in the first one, you see I'm going to get 2 over 1, which is 2. Excuse me. Trying to keep the color coding consistent. And the next one, I get 4 over 1, which is 4. And in the next one, I get 6 over 1, which is 6. Now, 2, 4, 6 may seem like a pattern, but just to go back to our idea of constant, it's not that there's a pattern. It's got to be never changing. It's got to be the same thing all the time. So here, although there's a pattern, it's not constant. 2 is different than 4 is different than 6. So this one is, in fact, not linear. So in this third example, okay, we're going to take a look again, same application, looking to see if delta y over delta x is constant. So I need to measure my delta y and delta x. It's a little more work on this one, okay? So pay attention as you compare and contrast these three problems in the end. Okay, so from 2 to 5, I know that one is 3. And 5 to 14 is 9. And 14 to 20 is 6. And they're all increases, so I'll put the plus signs, okay? Now, in the delta y column, 10 to 17 is plus 7. Now, 17 to 38, excuse me, if I don't know that off the top of my head, by saying how much did it change, change is always dictated by the difference. So it's just 38 minus 17, which in this fact is plus 21. And similarly, to go from 38 to 52, I could sit there and say, well, what's 52 minus 38? Which is 14. And you can involve your calculator if you so need to. Okay? So again, I'm going to be looking at not each individual delta value, but the ratio of delta y to delta x, and I am going to do that for all of these pairs. Okay, well, if you notice, I mean, they seem like they're both patterned, but it doesn't seem like anything is constant when I first look at it. This was 7, and then not 7, and then not 7 again, and this was 3, and then not 3, and then not 3 again. Which, to tell you the truth, if you look at this pattern over here, it's kind of obvious that it's linear, but just be patient and we'll take a look here and see what we get. So the first delta y over delta x is in fact 7 over 3. I'll hold on to that for now. The next one is 21 over 9. And the next one, in fact, is 14 over 6. Okay. Well, now if you notice this, they look like three fractions that can be simplified. Okay? And you can go on your calculator and get decimals, but just for the sake of practicing our simplification of fractions, I will, in fact, just leave them this way. So 7/3 can't be simplified, so it's 7/3. 21/9, they're both divisible by 3, so when I do, I get 7/3. And 14/6 is both divisible by 2, so when I divide them both by 2, numerator and denominator, I get 7/3. So it didn't seem so obvious here when I looked at it, but now that I look at the actual rates of change, they're all 7/3. So in fact, this one is linear as well. So a quick compare and contrast. I call this first problem sort of the easiest rendition of linear change in a data table, where all the delta y's match and all the delta x's match. So obviously, all the ratios match. The one in the middle, you have to be a little bit more careful because you get lulled into the idea, well, 2, 4, 6 is a pattern, so it must be linear. But that's not the case, because when I do the ratio of 2 to 1, 4 to 1, 6 to 1, I get something different than I'm looking for in each value. And then this last one, although it is linear, it's not as easy to see because the values of the deltas are changing. But again, you have to examine the ratios. So when you look at the ratios, they're all 7/3, which means constant. Excuse me, which means constant. And that means it, in fact, is going to be linear. So feel free to watch this again, practice all you want, and enjoy.